Okay, ladies, so let's start and with the second law of thermodynamics. So last time we covered all of these topics about the spontaneity of processes, and we agreed that the reason for spontaneity or the condition of spontaneity is that delta S total should be bigger than zero. That means it's positive. And we defined also the entropy in terms of heat and temperature. We solved a few questions as well. And we talked also about heating and the transition. I think that's what we covered last time. So let's do this again here. So for if you have a system like that, okay, and this system undergoes a process, and in that process you have S initial. S initial means the amount of entropy in that system before the process starts. And the process happens, okay, something happened to the system, maybe heating, maybe cooling, whatever. And now you are in a situation where you have S final. If delta S total, what does delta total mean? Bigger than zero. If it's positive, then this process is spontaneous. That's what this whole second law is all about. Where delta S total is equal to delta S for the system plus delta S for the surrounding. Now what I say next is extremely important. Now you have to listen to me. Today in this lecture, I will give you examples. Where delta S for the system increases, but the process is not spontaneous. You see that? That's very important what I said. I will give you examples. I can provide examples where delta S for the system is positive, but the process is not spontaneous. I can also give you examples where delta S surrounding is positive and the process is still not spontaneous. Because what happens here, you might have delta S, this is positive, but there is so much negative here. So when you add them up, delta S total will become negative, and therefore the process is not spontaneous. Are you guys following? Can I hear your voice? Yeah. For a process to be spontaneous means by itself, delta S total should be bigger. This whole thing should be positive. Yeah, bigger than zero. This whole thing should be bigger than zero. In today's lecture, I will give you what does that mean? That means you might have some positive. This could be positive and this positive, so that's good. Maybe this is big positive, this is a little bit negative, right? So when you add them up, the whole thing will be positive. So what I said a minute ago is that today I will give you examples where you have delta S for the system is positive, but the process is not spontaneous. Why? Because you have a lot of negativity in the delta S surrounding and opposite. You get that point, girls? I will explain this in a minute. Now, in the last lecture also we defined delta S to be equal Q reversible over T, where T is the temperature in Kelvin. And we solved some questions about that. And when I talk Q reversible, that means it's the heat that is taking place in a reversible step. An example of a reversible step is evaporation. When you have water, okay, my friends, and this water evaporates to gas, to vapor. So you have liquid here, you have vapor here. This process is reversible. Why? Because it's happening slowly. Also, you can do the reversible step at the same temperature. So this Q reversible in this case is equal to delta H for that transition. And from this, we define that delta S for the system is equal. By the way, when I say delta S, that means delta S for the system. If I want to say delta S surrounding, I will write delta S surrounding. So in this case, delta S for the system should equal to delta H transition divided by the T at that transition. Okay? So if you have, let's say, benzene is not the benzene you put in the car, it's benzene ring. You take organic chemistry, you know that, right? If you have benzene, and we're talking about the boiling point of benzene, I don't know what is it, maybe you can get it from the internet, it's maybe it's 80 degrees, around that. So you say delta S for the vaporization of benzene should equal to delta H vaporization of benzene divided by the T of vaporization of benzene. So T vaporization in that case will be 80 Celsius. You convert that to Kelvin. Delta H vaporization, you take it from whatever, from the sources, and from that you can calculate delta S vaporization. For the 10th time, I say that when you go from solid to liquid to gas, this process is endothermic. Right, guys? And when you go down, that means when you condensation and freezing, this is negative. This means it's exothermic. And therefore, when you calculate delta S for a process like vaporization, you expect this number to be positive or negative. Anybody? Now, so that's what the whole thing about thermodynamics is about. It's second law is that it defines a spontaneous process and speaking about the entropy. Now, there is something interesting about this exothermic endothermic processes. Now let's imagine that you have some liquid again. Let's say, sorry, that you have, let's say that you have some sugar, some glucose, and you burn this sugar. You burn it. What are the products? Anybody can tell me what are the products? Because this is well, energy is in terms of heat. H2 liquid, not gas. So this is exothermic process. You agree, guys? So this is CO2 gas plus H2O liquid, not gas, plus heat. This process is exothermic. In terms of thermodynamics, we say minus Q here, plus Q here, right? So for exothermic process, my friends, what do you think the temperature of the surrounding will happen? What happens to the temperature of the surrounding? Is it going to be increase or decrease? Anybody? Now here is the smart question. What's going to happen to delta S surrounding? You think it's going to be increase or decrease? Why you think it's decreasing? Or why you think? Yeah, endo, yeah. So it's taking heat. That means the surrounding is taking heat. Okay, so the temperature of the surrounding increases. So what's going to happen to delta S? What's the relationship between entropy and temperature? What do you think the okay, sure. So S is equal Q over T. So you're saying if this is constant, then when S increases, T decreases. You think like that? Okay, that's an idea. Anybody else? What do you think is going to happen to the delta S surrounding? Somebody said increase. Can you explain? Yeah, that's good. Yeah, that's right. Okay, but you have gas here as well. What about this, Nasima? Okay, I agree with you, Masha'il, but I'm just confused about, yeah, so Masha'il is right, delta S will increase. But Masha'il, what about this? What do you think about this, the entropy and temperature? You're not sure? Guys, the relationship between entropy and temperature is that when the temperature increases, entropy increases. Why? Because even delta S is equal Q over T, what happens is that here, yeah, I think it was, who said that before? Who was talking? Hanin, I think. Yeah, Yumna, the thing is here, when the temperature increases, Yumna, Q is also increasing. Okay? فاهمة Yumna? For this whole thing increases. This is not constant to the fair of that. Yeah, the Q is function also of temperature. فاهمة Yumna? But anyway, what Masha'il and the other girl said is right. You are taking heat from the reaction. So the Q, the heat in the products and the surrounding increases, and therefore the temperature increases of the surrounding, and therefore the delta S for the surrounding will increase for sure, and the opposite is true for endothermic. The opposite is true for endothermic. So if you look at the slide here, for a process at constant temperature, we define delta S to be equal minus delta H over T. هاي القانون إنه delta S surrounding بتساوي minus delta H over T. We defined a minute ago delta S للسيستم بتساوي delta H over T. So معناتها عندنا هون delta S for the system it's equal delta H over T. ماشي شباب؟ If you're working at constant temperature, at constant pressure, then delta S surrounding will be equal minus delta H over T. عكسها يعني. Last time when we talked about this question, if you remember, we solved one question here, I think, and see this question here? We said 120 for the system and minus 120 for the surrounding. So this is the rule. The rule is that delta S surrounding is equal minus delta H over T. Now for combustion, what is delta H? Is it negative or positive for combustion? Yeah, so delta H is negative. Let's say minus 200. So in this case, delta S surrounding is equal minus delta H over T. So it's equal minus 200 over T. T is always positive. Maybe it's 250 Kelvin مثلا. So the answer is positive. You see that? So whenever you have an exothermic process, delta H is less than 0, delta S surrounding is bigger than 0, and for endothermic, delta H is bigger than 0 because it's positive. Then in that case, delta S surrounding should be less than 0, which is negative. When in endothermic, you're taking heat, so the entropy of the surrounding decreases. Here is a question. Calculate delta S surrounding when 10 centimeter cube of water evaporates in an open vessel at 20 Celsius. Delta H vaporization of water at this temperature is 44 kilojoule per mole. Do you have any questions before I solve this one? Anybody? Do you have any concerns? This question explains it all. We have water, 10 grams of water evaporates. So it's good always to write streams of that. So 10 centimeter cube. We have evaporation. Evaporation means that delta H should be positive. Before I read number, I know that it's positive. And it is positive, so it's 44 kilojoule per mole. That's good. So I keep this number as is because it's positive and he's written positive. And this is happening at 20 Celsius. Of course, this number is not good. I have to change it into Kelvin. And he's asking to calculate delta S surrounding. Delta S surrounding is equal what? Now, this is evaporation. It's endothermic process. That means delta S surrounding should be negative. Why negative? Because in endothermic, you're taking heat. You can draw it like that. You take it heat from the surrounding to the system. That's what endothermic. This is plus Q. This is minus Q. شايفين يا بنات? So I am taking heat from the surrounding. I am taking heat from the surrounding for endothermic process. That means delta S should be negative. مظبوط. So you can write that the solution is delta S surrounding تكتب القانون minus delta H over T, which is, and you plug the numbers. It's 4 minus. This minus is from the formula. I didn't put it myself. 44 kilojoule divided by temperature. 20 is 293. Can anybody do this, please? How much is that? Banat, how much is this? Calculate. Sorry? 150 kilojoule Kelvin minus 1. That's okay. Oh, 155? Yeah, 150, whatever. Kilojoule Kelvin minus 1. And now, small. The answer does not write. Maybe this answer is in grams. Now, this one, 10 centimeter cube of water is equal 10 grams. So the number of moles is equal, maybe this is per mole. Does it say per mole? Oh, yeah, sorry. This is kilojoule. Sorry, this is kilojoule mole minus 1, Kelvin minus 1. So we need to get this mole out. So number of moles is 10 grams divided by 18. How much is 10 divided by 18? Anybody? Periodical, right? So how do you go from delta S? This is delta S. Now this delta S, is it the molar one or the regular one? Anybody? So we say delta S is equal delta N delta S molar. Do you remember this formula? Anything is like that. Delta H is equal N delta H molar. Q is equal N. And therefore, this is this number. So you can just multiply the number of moles times this. Then in that case, delta S is equal to the number of moles, which is 0.55 periodical, the number you get in the calculator, times this number, 0.150. How much is the answer? 15 شوي طلع 44 تقسيم 293 بتساوي 0.012. هذه 2 لازم تكون. بالمهم هلا times open bracket 10 divided by 18. The answer is 0.0834 kilojoule Kelvin minus 1, صح? Which is equal to, you multiply this by 1000, and now you get 83.43 joule Kelvin minus 1. صح هيك؟ Yeah. So it's in joule Kelvin minus 1. Anyway, this question, you put 2 stars on it. It's a very important question. Very, very important. Yes, that's a negative. Yes, tell me. Oh, because this is what you get. He gave you molar delta H, 44 kilojoule per mole, صح? You have to follow the units. That's why I told you to follow. It's very important to put the units. We are not in chemistry 101 here. You have to put kilojoule per Kelvin. So the answer is kilo. Oh, this is kilojoule per. Sorry, it's my mistake. This one is kilojoule per. يعني هون في عندك mole minus 1 in that question. Okay. Hello. Yeah. So guys, here this question is very important. I want to ask you, did we do this question in slide 15? Yes or no? بنات ما حلينا هذا السؤال احنا H2O solid goes to liquid sorry gas حكينا في heating وكذا. طيب ماشي. Okay. So what about did I tell you about this formula about the heating or cooling? Yeah, I did, and I think we solved this one, right? Hello? This one we did it. Okay, so in this case, when you have time here and you have temperature, you know the cooling and you can start with a solid and you heat the solid, right? And the temperature increases. Then when the solid melts, the temperature gets constant. Then if you want to, it converts to liquid, and they can heat the liquid, converts to solid, and then gas, and so on. So in this case, you have here solid, liquid, gas. Okay, so you have heating and cooling here. You can heat and cool the liquid itself, right? You can heat and cool down. You can also heat the gas or cool the gas. Same thing for the solid. In this area here, okay, you can call this area A. In this area A, you cannot choose delta S is equal delta H over T because T is not constant. In area A, this is not isothermal. The temperature is not constant. you have heating and cooling. You can say delta S is equal C. You can apply this formula here, which is C ln T fine over T initial. Okay, that's for A. But let's change colors here. In area B, here and there, now you have transition. In area B, this is isothermal process. Isothermal means the temperature is constant. In this case, you can say delta S is equal to delta H over T. Okay, so you have two formulas here. You have two different formulas. One for an isothermal transition, that means when the solid is going to liquid at its melting point, or the liquid goes to gas at its evaporation point. In this question, he's combining the two ideas together. He's saying calculate delta S for the transformation where you have H2O solid at 0 Celsius goes to H2O gas at 100 Celsius. You see, there are so many things here happening. For 1 mole of water, he's giving you the Cp for liquid water and the melting point, and also he's giving you delta H fusion for the water, and he's also giving you the boiling point and delta H vaporization. You have a lot of things happening here. So let's solve this question together. This is a very important question, and for sure it's going to come in the exam. انتبهوا. This is example in slide 15. Put 2 stars on it. Get your papers and pens up and wake up and let's do it together. Here we have H2O solid at 0 Celsius. I want to take it to H2O gas, see, at 100 Celsius. You cannot do this in one step. There are so many steps for this. First, you want to take the water, the H2O solid at 0 Celsius. You want to take it to H2O liquid, H2O solid at 0 Celsius. First, you want to take it to H2O liquid at 0 Celsius. That's easy. And then you want to heat the liquid. Heating the liquid, you have to apply another formula that you move to H2O liquid. You can convert it to gas directly at 100 Celsius. صح؟ تسخن liquid كمان. So this is step 1. And this is step 2. And this is, now you have a third step, you want to convert to gas now. You can do that. You can H2O gas at 100 Celsius. شايفين يا بنات? This is step 3. In step 1, you have to calculate delta S1. In step 2, delta S2. And in step 3, delta S3. Now questions. What does delta S1 equals to? Anybody? It's isothermal, so which one we apply? Delta H over T, right? So in this case, it's delta H melting, or we call it delta H fusion, divided by T in Kelvin, okay? And then you do it. You find the answer. Anybody can tell me what is delta S2 is equal to? Delta S2, this is not isothermal. You are heating the liquid, so you have to use the Cp ln T final over T initial. In this case, the Cp is given to you, and then you say ln final, T final is 100 Celsius, يعني plus 273, you convert to Kelvin, على 0 plus 273. And you find the answer. And delta S3, اللي هي from going to liquid to vapor, see that one there, you're converting liquid to vapor, that's evaporation, so you go and apply delta H over T again, but in this case delta H vaporization over temperature. All of these numbers are given to you, so that will you do it, okay? And then delta S total for the system, for the I will call it delta S for delta S. I don't want to call it total. خلاص call it delta S. It's equal to delta S1 plus delta S2 plus delta S3. I have a question, and then of course, I don't have time to do all the calculations. You do it, please, at home. But question: which feature of delta S I used here to say that delta S is equal this and that and that? Which one? What allows me to do this? There is something that says you can do this in thermodynamics. Why I did this? Anybody? Yes, Nasima, thank you. Because entropy is a state function. Because of the fact it's a state function, then I used this feature. When you solve this question, you're gonna have a small problem. The problem is that look at the H, it's in kilojoule per mole, but the CP is in joule per Kelvin per mole. So you have to be very, very careful with the units in this question. Okay? So when you do it, please do it right. And you have the answer there at the bottom. You can double check your answer. This question is extremely important, and I'm telling you right now, it's coming in the exam for sure. So we finish this and this, and now we are here. Question 218. The enthalpy of vaporization of methanol is 35.27. So we can also show you how to do that question. Delta H vaporization for methanol, it's equal to 35.27. Units are important, so kilojoule, mole minus 1. Boiling point is 64.1 TB, boiling point. For methanol, it's less than 100, of course. Methanol boils at this temperature, 0.1 Celsius. You change that into Kelvin right away. Calculate the entropy of vaporization of methanol at this temperature and the entropy change in the surrounding. Easy, very easy. You say delta S is equal delta H over T, right? So it's 35.77 kilojoule, يعني mole minus 1. في ممكن تعملوها على الكالكوليتر لو سمحتوا. divided by اللي هو بدك تحوليها كلفن، يعني 64.1 plus 273. حطيها ب brackets like this. يلا على الكالكوليتر كم بيطلع الجواب؟ لا بكيلو جو بير مول ولا ايش؟ Yeah, so you multiply by 1000 صح؟ Good. 0.104 كيلو جول مول minus 1 كلفن صح؟ plus مظبوط؟ And when you change it to joule, it will be 104. And delta S surrounding شو رأيكم بالدلتا S surrounding؟ شو بدها تكون؟ minus delta H over T. شايفين؟ which is it's equal to minus this number. تمام يا بنات؟ فهون الناس اللي نايمين خلاص فكروا الجواب 104. No, actually this answer is only for A, but for B it's minus 104 joule Kelvin. And by this I finished talking about the entropy. Now we move to something called the third law. Thermodynamics has three laws. The first law, delta U is equal Q plus W, and the second law we talked about it last time. And the third law of thermodynamics is the most amazing one. It says that the entropy of a perfect crystal of a substance is zero at V equals 0. Now, simply I can explain this way. Methane gas, do you think it has entropy or it doesn't have entropy? عنده entropy؟ طبعا عنده entropy كثير صح؟ طيب لو بردناه بصير CH4 liquid صح؟ هذا الانتروبي راح تكون اقل مزبوط؟ الانتروبي فور liquid صح؟ طيب معناته الانتروبي تاعت الغاز اكثر من الانتروبي تاعت الليكويد. طب انا لو بدي ابرده كمان CH4 methane solid, can I do that? Yes, I can do that. At extremely low temperatures it becomes solid. So now We have entropy for the solid, right? So the entropy of the liquid is even higher than the entropy of solid. But now I want to cool it down to 0 Kelvin. 0 Kelvin. شو يعني 0 Kelvin? That means 0 temperature. To the lowest temperature. Now this entropy becomes very low. This means the molecules are not even moving. But for CH4, as you studied in organic chemistry, there is vibration. These bonds can vibrate, so it may be at 0 Kelvin, it has some entropy. Now, if we take one atom, let's say helium atom, okay? This atom, when you cool it down to 0 Kelvin, there is no vibration, the atom is not moving, nothing. So in this case, the third law says that the entropy of that atom, يعني this order, is equal to 0. شايفين؟ ما في entropy، ما في أي شيء. سكون تام زي هالمحاضرة. Just like this lecture. Complete silence in, if you look at this helium atom at 0 Kelvin. Of course, 0 Kelvin is not practically reachable. يعني we cannot actually hit 0 Kelvin. I think people, they reach 0.4 Kelvin or something like that. It's near 0 Kelvin. Okay? But the third law says that at 0 Kelvin, atoms or single crystals, they have 0 entropy. Not molecules. Molecules, they have entropy at that temperature. Now, based on this fact, we calculate something called third law entropies. بناء على هذه الفكرة حسبنا ايش اسمه third law entropies او اللي هم اللي بيسموهم entropies. وهذول الانتروبيز هيهم موجودين في هالتيبل، شايفين يا بنات؟ فعندك at the entropies at 298 Kelvin، طبعا هذه entropies at room temperature، they have been calculated based on 0 third law. عندك الانتروبيز for many things، امونيا وكالسيوم وهيدروجين ونيتروجين الى اخره. Just like the enthalpies. Remember we have enthalpies at 298 Kelvin. Now we have entropies. Notice here that elements, they have entropies. Elements like hydrogen and nitrogen and oxygen, because these are not atoms. These are elements. So this is the difference between enthalpies and entropies. When we applied this equation before, delta S is equal to delta S for the products minus reactants. For delta H, we applied 0 for the elements, remember? But now this is not the case. You have to be careful when you solve this question. From that, you can calculate delta S reaction, which is basically just like delta H is equal to delta S for the products minus delta S for the reactants. A question here, the enzyme carbonic anhydrase catalyzes the hydration of CO2 gas in red blood cells. CO2 gas plus H2O liquid goes to H2CO3 aqueous. It says calculate delta S and comment on its sign. This is a very important question. Let's do it. جميل جدا هذا السؤال. طلع تعلمنا كثير شغلات. Question, it teaches you many things. Example in page 20. شوفوا سؤال HCO2 gas plus H2O liquid. انتبه, liquid, not gas. H2CO3 aqueous. Good. Now we need to do the delta S for this question, which is equal delta S for the products, right? Minus delta S for the reactants. تمام. Which is equal. Big brackets, small bracket for the products, minus, because we have only one product, minus maybe bigger bracket for the reactants. What is H2CO3? Maybe it's here. شايفين في H2CO3 يا بنات هون؟ carbon هي H2CO3 aqueous شايفينه؟ You see the mouse? Now you have three numbers. One for the molar mass, delta H, delta G, and S. We need S. So سجلوا الرقم هيو 187.4. So 187.4. منين جبناه من الجدول؟ Minus. We have CO2 gas. Does it appear in your slide? في عندك CO2 gas هنا. برضه ما في. We have to go to the table. CO2 gas, it's this one here. The entropy is minus 394. Sorry, this is delta G. This is 213.74. 213.74. And then plus اللي هو ال H2O liquid, you go to hydrogen. B, C, D, E, F, G, H, H2O liquid. It's right here. 69.91, is it? Yes, 69.91. It's for H2O liquid. And then you do the math and you find it. One راحت 69.91. Anybody can do this math, please? Yeah. There, of course, you will find different values. That's why we stick with this table, please. Yeah. And of course, there is H2CO3 gas, there is liquid, there is aqueous. It depends. Anybody can do this, please? Is it going to be minus number or not? Just tell me. Now, why it's negative number? This question is coming in the first exam. Why this? Why delta S for this reaction is negative? I just want to know that. Why? يلا يا بنات احكوا لي ليش هذا ليش طلع نيجاتيف؟ بدي افهم ليش طلعت نيجاتيف. بنات. Who's speaking? Who's speaking? Who's speaking? Harin, yes, tell me. No, it's okay. Just keep going. You were talking about products and reactants, صح Hanin? How many products you have? How many products? And how many reactants? Okay, that's the first reason. What is the most important reason? Anybody else can speak why delta S is negative? Yes. أحسنتي. What's your name, ما شاء الله؟ ندى اسمك عفوا ايش اسمك؟ لدن. ممتاز. شايف صح؟ Now you have gas here, you have liquid, so you're going to aqueous. The entropy of the gas and liquid are much higher than the aqueous. Okay? So this question is coming in the exam. Be careful. Huh? I will give you another one. طلعوا إذا عندك 2A gas, it goes to 3B gas plus C gas. What do you think the entropy of this question? Do you think it's positive or negative? Anybody? Why? Of course. We have 4 moles of gas here. We have 2 moles of gas here. So you have much more entropy in the product than you might have in the reactant. So this question is done. And now the time is, let me check. Yes, my friend. Good question. Good question. What's your name? She's asking, what if, teacher, we're talking about 2A liquid goes to 2B liquid? What do you think delta S for this is? The answer is we don't know. In that case, we need more information about that. We need to know if it's exothermic, if it's endothermic. You get that? ماشي يا بنات? And that's important of delta G, what's coming. Yeah, sometimes we cannot determine. So now we are done with that, and now we are going to finish delta G, and that will be the end of this chapter, inshallah. Now, any more questions, people? بنات كلش تمام واضح؟ Yes. Well, it is two. Yeah, it's a combination of both. Yeah, like you have also to look at the nature of the products and reactants. Sometimes you can judge. Sometimes it's clear, sometimes it's not. Like, like if you have here, let's say 2A liquid plus 4B مثلا liquid goes to مثلا C solid. واضح انه هاي عندك انت a lot of entropy here, there is less entropy here، صح؟ مزبوط؟ and also you have two reactants, you have one product. يعني واضحة الأمور. أحيانا ما بتكون واضحة فخلص يعني we cannot judge. The questions I will give you are clear، صح؟ يعني when I give you a question it will be clear to you. Okay? So the idea here is that just to link the answer in this question, the one we solved a minute ago, is just to link the answer with the fact of the question. Like here, it's clear that you have gas in the reactants, you have liquid in the reactants, you have also one aqueous in the products. So أكيد عندك entropy في reactants أكثر من the products. صح ولا لا؟ Okay, we have 10 minutes. Now, guys, I will give you two examples about what we just said, about what this lady asked me. These examples will give you the need that we need something else other than delta H. Delta H will give you its exothermic, endothermic, and something other than the entropy to judge if the reaction is spontaneous. طلعوا يا بنات هذا المثال، الكل ينتبه الآن رجاء طلعوا حتى if you are sleeping wake up. This process happens in your body. There is something called nicotinamide adenine dinucleotide. It's NAD+. Did you study this in biology somehow? It reacts with this LDH enzyme to form NAD-LDH binding. So this process, what do you think delta S for this process? Anybody? شو رايكم بهذه البروسيس؟ عندك two things combining to form one thing. What do you think delta S? Is it going to be increase or decrease? Decrease، صح؟ تتوقع هذا الرياكشن بناء على الحكي هذا، بناء على الكلام هذا، delta S, is it going to be do you think this process is spontaneous or not? If delta S is negative, اكتب هنا الجميع delta S negative للسيستم. Yeah, in fact this process is happening and it is spontaneous. صح؟ هذا التفاعل بيحدث لوحده في جسمك انت في البادي. معناته هون دلتا اس نيجاتيف بس this is spontaneous. So معناته مش دلتا اس وحده اللي بتحكم. It's not only delta S that is govern things. We said at the beginning of the chapter is that delta S total should be positive to be the reaction to be spontaneous. Don't make the mistake of judging delta S system. If delta S system is negative, that means it's spontaneous. No, it's not about that. This is an example of a reaction with negative delta S for the system, and it is also spontaneous. One more example. Magnesium solid reacts with oxygen to form MgO solid, MgO gas. I will show you the video. This is a beautiful video. We used to do this with our students in the old days when we when we were in the real life. Now we are living virtual life. Okay, I will stop here. Did you guys enjoy this? I used to do this with my students in the real world. Now we are in the virtual world. So unfortunately, we cannot do that. So guys, a question. By the way, let me ask a funny question. For the people who are taking the lab, is there something wrong in this video anyway? Do you see anything like hazard or anything that is? Yeah. Yes, Lemon. Yeah, he's not wearing a lab coat. That's good. Anyway, well, he's confident of himself. So is this process spontaneous or not? Anybody? Do you think this process is spontaneous or not spontaneous? He said that in the video. Okay, so write this down in slide 22, everyone. Right? This is a spontaneous process. It happens by itself, right? You just give it the heat and it happens. It goes. A spontaneous process is a process that goes to products, like the reactants goes to products. That's what spontaneous mean. It's not the products goes to reactants. You cannot convert MgO solid by its spontaneously to magnesium and oxygen. Now the other important question is, what is delta S for this reaction? From the equation in front of you here, I want you to look at the equation and tell me what is the sign of delta S. Is it the negative or positive? Anybody? Negative. This is another example of a process, ماشي شباب, if a process that is with delta S negative and it is spontaneous. By the way, this reaction is exothermic, this reaction is endothermic. Write this down as well in slide 21. This reaction, the NDH, the NAD plus and the LDH goes to this complex here, the binding. This is one molecule. You can think about this as one molecule or one complex. This is endothermic reaction, delta S is negative. This is exothermic reaction, delta H is negative, and its delta S is negative. So what's happening here? How come? That's why we need a new thing. That's why we need a new thing. The new thing is that you never judge a reaction based on its exothermic or endothermic. It should be that delta S universe. Delta S universe, that means delta S for the whole thing, for the system and the surrounding, should be positive. I will give you two more examples. Watch this. Examples from your daily life. Ice, when it melts to water, what do you think about delta H of this? This is solid. This is liquid. What do you think about this? Just tell me, negative or positive? What do you think? Which one is negative? Delta H is positive because this is melting. صح? This is endothermic. And delta S is what? Negative or positive? Anybody? Okay. Now, this process happens spontaneously at let's say 20 Celsius. But at minus 20 Celsius, the opposite is happening. That means the water, when you put water in the freezer, water liquid goes to ice solid, where delta H for this is negative and delta S is positive, and it's also spontaneous. So both processes are spontaneous. So you cannot judge, the take-home message is that you cannot judge if the process is spontaneous or not based on looking at just the signs of delta S and delta H. That's why we need a new thing. That's why we need a new parameter that tells us for sure if the process is if this process is spontaneous or not, which is delta G, the Gibbs free energy. Gibbs free energy, it's something that people make up, just like the enthalpy. G is equal H minus Ts. That's the definition of the Gibbs energy, my friends. And this is the Gibbs energy. This is the one that tells us if this process is spontaneous or not. If you're considering a change, because the Gibbs free energy itself is a state function, you see delta G is equal delta H minus D delta S. This is one of the most famous equations in thermodynamics, to the level that people usually forget what they studied in thermodynamics. Like everybody who took thermodynamics, after 3-4 years, you tell him, do you remember anything? You say no. I just remember delta G is equal delta H minus D delta S. يعني كلنا كنا نتذكر هذه المعادلة إنها مشهورة جدا. This is very famous reaction. Delta G, if it's negative, green light, go, it's spontaneous. If its delta G is bigger than 0, if it's positive, it's non-spontaneous. You have to stop the red light. That means this reaction is non-spontaneous. So this is the rule now. We have a rule, a golden rule. If delta G is negative, that means we have enough free energy for the system to go and proceed from reactants to products. Otherwise, if the delta G is positive, then it is non-spontaneous. And we're going to discuss this, inshallah, in the next lecture. It's only 2 questions and we finish this chapter. And on Wednesday, for sure, we're going to start chapter 3.